It's talking about area ratios and similar polygons. We're going to answer the question, how does the area change? So question 53 is about the school's mascot. It's called the Mighty Mascot. To celebrate the victory of our school's championship girls ice hockey team, the student body decides to hang a giant flag with your school's mascot on the gym wall. To help design the flag, your friend Archie creates a scale version of the flag measuring 1 foot wide and 1.5 feet tall. Okay, so this is Archie's right here. It's just a small one, like on a piece of paper, right? The student body thinks the final flag should be 3 feet tall. How wide would this enlarged flag be? Okay, so if the original flag is 1 foot by 1.5 feet, if we want it to be 3 feet tall, what are we multiplying 1.5 by to get to the 3? 2. So that would mean instead of being 1 foot wide, it's going to be 2 foot. So the flag would be 2 feet wide. They're going to be proportional, similar, so that you're going to multiply by the same thing. Whatever you multiply one side by, you multiply the other side by the same thing. Part B says, if Archie uses $2 worth of materials to create his scale model, how much will materials cost for the full-size flag? Discuss it with your team. I want you to make a prediction on your paper, and you're going to say, I think the cost will be, and then you're going to write in what you think it will cost. Part C says, obtain this resource page, and I'll give it to you in just a minute, and I'll give you some scissors. You're going to carefully cut enough copies of Archie's scale version to fit the large flag. You're going to answer the question, how many of the smalls did it take to fit inside of the big one? And then, does this confirm your answer to part B? If not, what will the materials cost of the full-size flag? So you're going to answer the question, and you're going to fill in the number. It took blank amount of small flags, and the actual cost will be blank dollars. Okay? You're going to decide that in your group of 4. Okay? Part D says, the student body is reconsidering the size of the flag. It is now considering making an even larger flag so that it will be 3 or 4 times the width of Archie's model. How much would the materials for a similar flag that is 3 times as wide as Archie's model cost? What is the flag, or what if the flag is 4 times as wide? Okay, so for this one, you're going to fill in what you think it's going to be 3 feet and 4 feet. Okay, and I'll give you all the pieces that you need in a minute, and you'll say it took blank amount of the small flags, and the cost will be blank dollars. Same thing for the 4-foot flag. It's going to take a certain amount of the small flags, and then you're going to figure out the cost. Okay? Then in your groups, you're going to answer question 54 together, which says, write down any observations or patterns. So you will notice a pattern. There will be an observation there will be something for you to write down. Okay? 55, it says, use your observations and patterns from problem 54 to answer the following questions. Kelly's shape at the right has an area of 17 square millimeters. If she enlarges the shape with a linear scale factor of 5, what will be the area of the enlargement? Show how you got your answer. Okay? So the area of the shape will be 5 squared. So you're going to take the linear measurement of 5, you're going to square it. 5 squared is 25. So if the area of this one was 17, You're going to multiply the 17 times the 25 to get a full area of 425 millimeters squared. Okay. Part B says examine the two similar shapes at right. What is the linear scale factor and what is the area of the smaller figure? Okay. So if we're going from the larger figure to the smaller figure, we're going to take the 40 and divide it by 10, which means it's a factor of 4. We're going to square the 4, which is 16, and then 656, which was the area of this one, divided by 16. So now we're going the opposite direction. The area of the smaller figure is going to be 41 inches, or is that inches? Units squared. Okay? Couldn't read that. Part C says rectangle ABCD below right is divided into 9 small congruent rectangles. The shading on yours might not be very dark, but only these 4 boxes should be shaded. The rest of them are not shaded. Okay? So the question is, what is the linear scale factor? And then what is the ratio of the areas? If the shaded rectangle is not similar to ABCD, explain how you know. Okay, so the linear is going to be a ratio of 3 to 2 because the large rectangle was 3 units by 3 units. And then the smaller rectangle is 2 units by 2 units. So we did the large to the small. So a 3 by 3 to the smaller rectangle, 2 by 2. So for the area, it's 3 squared, which is 9. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 total in the large rectangle, and 4, 1, 2, 3, 4 in the smaller shaded area. Okay. Part D says, while ordering carpet for his rectangular office, Trin was told by the salesperson that a 16 by 24 piece of carpet costs $800. Trin then realizes that he read his measurements wrong, and then his office is actually 8 foot by 12. Oh, that's no problem, says the salesperson. That is half the size and will cost $400 instead. Is that fair? Decide what the price should be. Okay? So if the office is actually 8 by 12, the area of the office is only 96 units squared versus his incorrect measurements of 16 times 24, which is 384. The salesperson said it was twice as big. That is not, or half the size, but it's actually a quarter of the size. So you should take 384 divided by 96. That means it's not half the price, it's a quarter of the price. So you want to take 800 and divide it by 4, not by 2, which gives you a way better price of $200. So you don't get scammed by the carpet guy trying to charge